Exactly.
So,
Yes.
then what is the functor that takes you from Euclidean space to Minkowski space?
I don't know. This is what this hypothetical summer winter school student would have to figure out. I don't know.
Right.
Xerxes, do you have any ideas?
I don't know what the functor is, but in practical computations, one would do a weak rotation. So you need a functorial generalization of a weak rotation, or
Right.
at least to check in under which conditions is such a rotation well defined.
Yeah, which is a total mess. I mean, the notion, well, in the practical, in the trenches quantum field theory, the validity of Wick rotation is a total mess.
Exactly.
Right. But so, hmm.
But
Yeah,
it's a
okay.
mess because it's not well defined. Uh, it's not a mess because it's the I mean it has the right intuition. It's just that one still has to identify the constraints under which it is well posed on that structure.
Yeah, but I mean, for us, if we look at our causal graph, which is defines a partial ordering, then to discuss a Wick rotation is to turn that causal graph into essentially a spatial graph.
Right.
That's what it would mean. Is we're Yeah, that's an interesting question. What is the I mean, a Wick rotation attempts to define.
I
Okay,
would
so
argue it's swapping branchial graphs and spatial graphs.
that's not the traditional Wick rotation. I agree that that's an interesting case. But here, let me give a different example. What class of graphs have the feature that they can be created as causal graphs, as partially ordered, as directed causal graphs? Right? You could imagine you have Euclidean space. I mean, okay, you're doing lattice gauge theory. You have this Euclideanized space-time. And then you say, oh, you know, under what circumstances are the field configurations that I'm getting ones that could exist I mean, like for example, imagine that you have a propagating wave, which of course doesn't happen in Euclidean space. Uh, I mean, in other words, you're saying of the things I see in Euclidean space, when do I get Euclidean spaces that can reasonably be Minkowskified? Were you saying something different, Jonathan?
Well, no, I don't understand why that's not the conventional Wick rotation. Because in the canonical sort of decomposition of these things, you would say, okay, I have time, I have the causal edge distances that are giving me negative contributions, negative eigenvalues of the metric. I have space-like distances that are giving me positive eigenvalues of the metric, and I have branch-like distances that are giving me imaginary values of the metric. And what the Wick rotation I assumed was my understanding of it is that it's just encapsulating the imaginary eigenvalues into the definition of the time-like direction, so you get a Euclidean signature.
Well, that will be a very interesting generalization of Wick rotation, because actual Wick rotation is simply Euclideanifying Minkowski space. Nothing to do with quantum mechanics. I mean, what you're defining is a very
Well,
interesting generalization.
but this is no, but this doesn't even have to be explicitly quantum mechanical. This is just how do you go from an arbitrary metric that has positive, negative, and imaginary eigenvalues?
Yeah, I get
And,
it. Right.
right.
But I think
And
there's a different thing that given that we now know, okay, so this is an important point. I mean, given that we now know that there's, branchial space and there's physical space, right? The 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 thing that has previously been done is to treat time to treat the time-like direction with respect to space to merge together the time-like and space-like directions. So we have two new things to do. We can merge the branch-like and time-like directions, and we can do something crazy with the space-like and branch-like directions. And these are all forms of Wick rotation.
right, right. And my claim is that the most conventional form, where you're just incorporating, you're just including the, minus I tau uh, dependent in the definition of the time-like directions, is the same as switching the space-like and branch-like directions, and then swapping over the metric signature of branch time.
Well, that's a major claim. It might be true, But that's an entanglement of Wick rotation with quantum mechanics, which is just not something that's known.
No, but just on a purely formal level of how do you take this metric and how do you turn it into one that's Wick rotated?
No, I get it. I mean, that's a formal claim which has a physical consequence that says that Wick rotation has something to do with quantum mechanics, which normally it doesn't. But okay.